Hello everyone, I am Dr. Rajesh, and today in this lecture we will study an important problem based upon Lami's theorem. So please have a look at its statement. A uniform lamella in the form of a rhombus, one of whose angle is 120 degree, is supported by two forces P, Q applied at the center in the directions of diagonals, so that one side is horizontal. Show that if P is greater than Q, then P square is equal to 3Q square. Let us first form a rhombus. Then we will see a rhombus is a figure that has all sides equal. Rhombus differ from the square in the sense that each angle in rhombus need not to be 90 degree. So rhombus is like a parallelogram whose sides are equal. So let me draw the rhombus first, then we'll see. And one of its side is horizontal. So say this is the one side of a rhombus, fine, and one angle is 120 degree. Make it equal of the, this is another side, fine, and opposite to this, parallel to this one, of the same length. This is another side, fine, and all sides are equal, fine. All sides are equal. So let me make it so. This is a rhombus whose all sides are equal, and one of the angle is 120 degree. Clearly this angle is less than 90 degree, because 90 degree is this much angle is 90. This is less than that, so this angle is not 120. So which angle will be 120? This angle will be 120 degree. So let me mark the angle. This angle is 120 degree. Fine, so let me mark this angle as 120 degree, and also let me name the vertices, say A, B, C, D, fine. So now this is a rhombus whose all sides are equal and one of the angle is 120 degree, and we know that in case of a rhombus opposite angles are equal. So this will be 120 degree, and this sum is 180 degree, so this angle will be 60 degree, and this will also be 60 degree, fine. One of the property of rhombus is that its diagonals do intersect each other at right angle. So let me draw its diagonals, and those diagonals will intersect with each other at an angle of 90 degree. So let me draw first diagonal starting from here going up to there. So this is the first diagonal, and now let me draw the second one. This is the second diagonal, fine. So and these diagonals do intersect with each other at right angle. This is the property of the rhombus. This angle is 90, this is 90, this is 90, this one is 90, so each is 90, fine. This is the property. And let us suppose that W is the weight of this rhombus, and weight we know that acts at the center of gravity, and center of gravity in case of a rhombus is at the intersection of the diagonals. So the weight of the rhombus, that is capital W, will act at the center of gravity, which is in case of a rhombus it is at the intersection of the diagonals. So this weight will be acting vertically downward at the center of gravity, which is at the point of intersection of the diagonals. So this is the weight acting vertically downward. Now let me show you, and you will try to understand the positioning of the forces P and Q, which one will be P and which one will be Q, and what will be their direction. That is important point. And say this point, the center point, is named as O. Fine. So if there is no force upon this rhombus along the diagonals, so what will happen? Because of its own weight, this rhombus would try to fall in the forward direction. It would try to collapse. This BC would try to become horizontal in this direction. This AD will try to become horizontal in this direction, and this will be aligning in a single particular line if there is no force acting along the diagonals. So this rhombus will fall down in this particular direction. It will fall down. So now in order to stop it from falling down, so as this AD will try to move in this particular direction, so we have to apply a force along this diagonal, and the direction of the force is, if it is moving this side, AD is moving in this direction, so we have to apply the force so as to stop it from falling in this direction or moving in this direction. If we want to stop it from moving in this direction, we are required to apply a force, and that moving in this direction is due to its weight. We have to stop it, and if we want to stop it, we have to apply a force. Say it is force P we have applied in this direction. Now it will spot. It will try to stop it from falling in this particular direction. So the direction of the force, I think, is clear. It would be in this direction. And why it is P, not Q, I will also explain. Now since we have applied a force in this direction, now if there is no force, then what will happen? It will try to take this AD in this particular direction. Okay, so this will also try to move in this direction so as to stop moving this BC in this particular direction under the influence of Q. We will apply a force, and to stop it moving from this direction under the influence of force P, we need to apply a force, another force Q, and that will be in this particular direction. I think I am clear in explaining the directions of forces P and Q. Now last point that I am going to explain why I have chosen this as P, not this as P. Why this is the lucky one that I have written it over here, not over here. This is also scientific. We cannot write it randomly. We have to see what is the physically going on in the figure, and how we have to make the figure in equilibrium. So that will explain why we have taken here P, not here. See, this P is spotting two things. One, it is spotting this AD and stopping it from moving in this direction. Secondly, it is also spotting the weight. It is also spotting the weight of the rhombus, because if there is no P, it is natural that the whole of the rhombus will try to move in this particular direction. So as to stop it from moving in this direction, we have to apply a force that will negate not only the moving in this direction, but also negate this effect, that is W, the weight of the rhombus. So obviously P has to be greater than Q, because it also has to spot the weight of the rhombus, while this force is not spotting the weight, because weight is trying to move this whole figure in this direction, and this force is also trying to move this in particular direction. So this is not supporting the weight of the rhombus. So this particular force is only supporting the weight of the rhombus. So this there lies the extra responsibility upon this force to support the weight of the rhombus and to keep this rhombus in under equilibrium at point O. Now since this whole system is in equilibrium and the forces P, Q, W acting at point O are in equilibrium, therefore I can use the Lami's theorem. So I will write that forces since forces P, Q and W acting at O are in equilibrium. Therefore, using Lami's theorem at point O, Now let me explain the angles. First, concentrate upon this figure only. P, take the force P, angle between W and Q. This angle obviously is 90 degree. Okay, written. But what is this angle? We know that diagonal intersect this particular angle into equal angle. This part is 60, this part is 60. So let me write it as this part and this, both these parts are, this is 60 and this is also 60 degree. Fine. So this is 60 and this one is, because this is given as horizontal and weight is acting vertically downward, so this angle is 90 degree. So in a triangle we know that sum of the angles is 180 degree, so this is 30 degree, this is 30 degree. So now if we take P, the angle between Q and W will be 90 plus this is 90 na? This is 90 degree, 90 plus 30, it will be the angle between Q and W. Now if we take the Q, what will be the angle between P and W? See, this is 60 degree, so this will also divide it into two equal parts. So if I say that these angles would be equal, this will be 30 degree and this would also be 30 degree and this is 90 degree. So this angle we are left with 60 degree. So if we take Q, the angle between P and W will be 90 plus 60 degree. So it will be 150 degree. Fine. And when we take W, the angle between P and Q, obviously it is showing that it is 90 degree. Now applying the Lami's theorem, this is P, this is Q and this is W. Write the angles. This is sine. Fine. P, angle between Q and W, you know now. This is 90, this is 30. It will be 90 plus 30, writing it as such. Fine. Sine Q, angle between P and W, it will be 90 plus 60. plus 60, and we take one W, angle between P and Q is 90 degree. Fine, this is 90 degree. So now you know P sin 90 plus is nothing but cos 30 degree. Fine, and Q again sin 90 plus 60 degree is nothing but cos 60 degree. Fine, W by 1. But we have to find the relation. You look over here, find the relation between P and Q. So we will take the first two terms so that we could arrive at some relation between P and Q. So taking first two terms, taking first two terms of above equation. Fine, it will be P cos 30 degree is equal to Q cos 60 degree. Fine. And what does that imply? This implies that P cos 30 you know is root 3 by 2 and Q cos 60 degree you know 1 by 2. So 2 to 2 will cancel out. This implies that P is equal to this root 3 will move over there. It will be root 3 Q, and now squaring both sides we will get P square is equal to 3Q square, and you will also mention that where P is greater than Q. So this is the result that we were required to prove, and we have proved it successfully, and this was the result that we required to prove. And here P is greater than Q. This has got importance. We cannot choose the forces randomly. We have to choose the forces based upon the geometry of the figure. If we take this in this direction, then this is this one, and if we take otherwise, if we will take the rhombus in this case, then we will choose P and Q accordingly. So you will also try with that also. When you will take the rhombus, I will mark it. You will try it at your own. When you will take rhombus of this side, this type, fine, you will try it. So in this case you will try that which force will be. So I am also explaining you. Let me show you. If in this orientation you will take, let me draw the diagonals. So we don't need to remember anything. Everything is very much clear in static. If this will be the direction and this is the weight, fine, this is the weight W. Now see, in this case this will be 120 degree. Now under the weight, this rhombus now would try to fall in this particular direction. So as to support its weight also, we need a force P. Okay, this is the P in this case, because it is supporting, so as to move it from this direction. Now when this force P is applied, it has tendency to just stretch this rhombus and make this side AD, to move in this particular direction. So as to stop this from moving in this direction under the influence of force P, what we do, we apply a force Q. So this will be Q in this particular direction. So these will be the direction if we take the rhombus in this particular orientation, and obviously sum of these two angles is this is 60 degree. Fine, and opposite angles in rhombus are equal. This will be 120 degree. So I leave it up to you, and in the examination you can form either the figure in this form or in this form. It is up to you. Don't remember that we have to take the figure in this orientation only. We cannot take in this particular orientation. So from the both way we will get the same result, and it is up to you, because you can take it either way. There is no compulsion that you have to take only this type. You can also take this type also, and I have explained it. So this question is an important question based upon the Lami's theorem. So you should mark it as important question, and this question was making use of the Lami's theorem and the forces orientation, the selection of the forces along which force will along the which diagonal. So that is also important. So I hope that you will be able to understand this question, and that is all I have from this lecture. And if you like the lecture, please like, subscribe, share and comment. This is Dr. Rajesh saying goodbye, take care, bye bye, and see you soon.